A linear relationship is basically anything in the form of y equals mx plus b. This can be used to model situations. M equals the gradient and b will equal the y-intercept. Okay, so the gradient is like the slope. Now when we're looking at this one here, water is being poured into a container. The graph shows the depth of water at any given time. Now if you look at this particular graph, see how it's a straight line? So that means that the water is going up at a constant rate. And if you look at this particular one here, if we look at this one here, you notice that when the water goes in, it goes up at a constant rate. So the answer will be B. If you were looking at something that like this, then it goes up at not at a constant rate. It goes from quite fast to slowing down at the end. So the graph would be quite fast to slowing down at the end. But if it was something like this, like that way, then it would be quite slow, then it gets more rapid towards the end. So it goes up quite slow and gets more rapid at the end. All right, now you can use linear relationships, you can use linear relationships as a model for cost. Now, N is the number of students, and the thing is that 2 in front of there, that would be the cost per student. So that's like your rate. So it's the cost per student times N, which is the number of students, plus the 5. So it's 2 times N plus 5. The 5 represents the fixed amount that you pay, even if there were no students, and the 2 represents how much per student. So if 3 extra students go on the excursion, how much does the total cost increase? Okay, so you haven't really got an amount there. But let's just say what you could do is just put in a dodgy amount. Let's say 10. So 2 times 10 equals 5, so that's 25. And if you increase it by 3, that would be 13. So it would be 2 times 13 plus 5. 26 plus 5 is 31. So can you see that it would be, from 31 to 25 would be an increase of $6. Now another way of doing that is because it's $2 per student. If you put in an extra 3 students, that would be $6. Now I just want to run through basically, like if you hired something, like let's say you hired a hall, and the upfront cost was $300, plus we're going to charge $20 per person. Okay, then the actual formula for finding the cost, where N equals the number of persons, would be your 300 plus 20 times N. And this actually, see how it's in the form of Y equals MX plus B? The $20 is the rate per person. That represents the gradient. And the $300, that's the fixed upfront payment. And that amount, the fixed upfront payment, that amount will represent the amount that you pay even if no person steps on the bus, okay? And as far as the straight line is concerned, it is actually like the y-intercept, or the place where it cuts the vertical axis. So if we were just looking at this graph and we wanted to sketch it, so if you're looking at that graph and you wanted to sketch it, then you got N and C. So it's 0, 10, and 20. So if you put in 0, the cost would be 20 times 0 plus 300. So it's 300. if you put in 10, it's 20 times 10 plus 300. 20 times 10 is 200. Plus 300 would be 500. And 20 times 20 plus 300. 20 times 20 is 400. 400 plus 300 is 700. So it's 500 and 700. And if you now plot that graph, so if you plot it onto a number plane, now it's quite hard to actually get that number plane how we want it. Just wait 1 minute. Okay. No, I think what we'll do is we'll just plot our own one. So I'm just going to draw one, because when I do the cost and I do n and the cost both have to be positive. Oh, you suppose you could have a run it at a loss. So when x equals 0, you got 100, 200, 300, 400, 500, 600, and it will go all the way up to 700. So 100, 200, 300, 400, 500, 600, and 700, which is C. And then you go 10, 20. So when it's 0, it's at 300. When it's 10, it went up to 500. When it was 20, it went up to 700. So then if you drew the line that went through there, it would look like that. And I want you to realise that then if you drew a triangle like this and down like this, then that right angle triangle, this would be 20 along here, and from 300 up to 600 is 300. Okay, so this is 10, 20, and 300, it's 300 up to 700, so it's 400. If you looked at the gradient, see the gradient is 400 over 20, which equals 20, and you notice that actually matches in this equation. It will match this 20 that I'm timesing by each time in the formula. So it's that 20. Okay, so I just want to look at this last one. This is another linear model example. So a plumber charges a call-out fee. So the call-out fee is $90, so the cost is $90. See, that's your fixed amount or your y-intercept. Just notice this one too, how I said that 300 was the y-intercept. You can see it intersects the y-axis there at 300, okay? So it's all sort of backs up the equation. So the cost is $90 plus $2 per minute. So let M be the number of minutes. Okay, they got T as the number of minutes. So put T. So 90 plus 2T. So it's going to be B.